In this video, guys, we're going to Section 3, Chapter 9. We're skipping Section 2 temporarily. We'll get to it when we get to Chapter 10, because Section 2 of Chapter 9 talks about circles. And we're going to lump that together with all of Chapter 10, because that's what Chapter 10 is on, circles. So here we go. We are going to talk about today, Section 9.3. Day 1, you see here, it says altitude day. We're not talking about the altitude that this plane's flying, what a pretty little plane that is. But we're going to talk about this Theorem 68. And you have the paper I gave to you in class already. It's called the Altitude on Hypotenuse Theorem, AOH. And there's 3 parts to it, as you see in the paper right there. This video will cover 2 of those. The very first one is really the foundation, if you will, for letter B and letter C, the second 2 parts of it. So let me give you a little reminder, though, of kind of what you're going to be using a ton in this video. Yup, you see it. It says mean proportional. That was last chapter. We just took a test on that bad boy, and we talked about mean proportional a ton. And remember, that was this: if there was something called the mean proportional, that meant you put the x's in for the means. So right here where this x is and that the means, that's the mean proportional between the other 2 numbers, 9 and 64. So when you solve this, you know, means extremes product theorem, you do the old I dream of Genie, do that, wonderful. So you get x squared equals 576, and then you do this bad boy. You take the square root of both sides. That's right, to solve it, you know that. So the square and the square root cancel each other out, and then what that gives you is, what happened to my drawing? Sorry, square root and square root. So the square and the square root cancel each other out, like I said, and that gives you x equals 24. So wonderful. Now wait, did you catch the mistake? I did it on purpose. Did you miss it? Remember, when you take the square root of both sides, ladies and gentlemen, it is always plus or minus. Always plus or minus when you do square root. Always plus or minus when you do the square root of both sides. So technically, there are 2 answers to this question. It is positive 24 or negative 24. That's going to come into play here when we get to the examples in the next video. But mean proportional is a nice little reminder. Also, here's a nice little reminder. Let's go to this, our friendly little right triangle reminder. Remember, in a right triangle, we talked a ton about these things so far. This is a right triangle because there's a right angle there, so we know that for a fact. AC, this side of the right triangle, and CB, that side of the right triangle, had special names. They were called legs. And the side that's across from the 90-degree angle is always called the hypotenuse. Kidding, it's called the hypotenuse, but I just say hypotenuse so I can spell it right. Now, in this video, or in this section, the altitude on hypotenuse theorem, Theorem 68, deals with a right triangle. Ladies and gentlemen, can I tell you something? If you do not have a right triangle, then this theorem does not apply. You might as well rip it up and throw it out. It means nothing unless you have a right triangle. I hope you write that down. That's actually a very important thing. I highlight it. Very important. Anyways, so what's going to happen is this. There's going to be an altitude that we're going to be drawing to the hypotenuse of a right triangle, and the pictures are all going to look like this. So we have altitude drawn to the hypotenuse of a bigger right triangle, and that thing right there is the altitude because it creates a right angle, and it creates other things. Like I said, there's going to be 3 parts to this video. So here we go. And this looks exactly like the sheet of paper I gave you. You can take the notes on this like I said in class, or you can do it on your own notebook wherever you want to. However, here is the first thing. You can see how the theorem starts. If an altitude is drawn to the hypotenuse of a right triangle, then, well, before we even write this down, don't write this down, let's just think about this. What do you think we could conclude about the triangle ADC, that's this triangle here on the left, and the overall bigger triangle ACB? Well, one thing that I see, probably the same thing that you do, is this. This angle up here, angle C, is right over here, so that's a right angle. This angle here is a right angle, which makes this a right angle. We know that. So that's this angle over here. So far, we've got 2 angles in the triangle congruent. We got 1 pair of angles, sorry. So we only need 1 more to prove them similar. Guess what? If I look at this angle, that's the same as this angle. But wait a minute. That angle right there is the same thing as this angle. It's a shared angle in this triangle and that triangle. So right away, you can see very quickly that we got these triangles similar through the squiggy theorem. Lovely. So that's one thing that you can actually see that happens when you have an altitude drawn to the hypotenuse of a right triangle. So what else do you think we can see? Well, here's the next question. What about triangle CDB and triangle ACB? So that's these guys. Triangle CDB is the triangle right here, CDB, and then the overall bigger right triangle. Well, I could do the same exact argument, guys. There's a right angle, check. This guy up here is a right angle, check. That's the overall bigger right angle. And then this angle B is being shared in this triangle and also that triangle. So again, same concept. Those two triangles would be similar through the squiggy theorem. So that leads to part A, and this is what should go into your notes for sure. This is the first part of this particular theorem, altitude on hypotenuse. So what happens is, if you have an altitude drawn to the hypotenuse of a right triangle, there's three triangles that's formed, and no matter which triangle you take, they're going to be similar to each other. That is awesome. By the way, like I said before, that sets the stage for letter B, part B of this theorem, and part C. Let's dive into that right now. So here's what you're going to see. If you didn't notice this already, I put an H right there for the altitude. I put X right there. That represents the piece from A to D. That's a little individual segment of the overall entire hypotenuse. And Y represents the length from D over here to B. Again, that's another individual segment of the overall entire hypotenuse. So here's what part B actually says. We're going to look at, again, strictly this is altitude data, so we're only looking at the altitude. Here's the wording of part B. It says the altitude length that is drawn to the hypotenuse is the, and it's underlined for a reason, people, mean proportional. So this altitude length is the mean proportional. Now think about, no pun intended here, what that means. Anyways, so that's the mean proportional between the segments of the hypotenuse. So here is the exact, right there, that is the exact proportion that you're going to set up. Now you might be sitting there thinking like, how does that come about? Well, check this out. If we go back to part A, where we knew that triangle ADC was similar to triangle CDB, we knew that. That's the triangle on the left and the triangle on the right. Watch how cool this is, guys. You're going to see this. Watch me do this. Since we know that triangles are corresponding, we know from chapter 8 that their corresponding sides are similar. So since the triangles are similar, I might have said that wrong a little bit ago, forgive me. Since the triangles are similar, we know their corresponding sides are proportional. Watch this. AD, that happens to be X. It matches up over here to CD. That happens to be the altitude length. So let me put that as a proportion, or a ratio, sorry. So X is to H. That's a pair of corresponding sides. So, and you see as I keep going, DC, oh wait, DC is the altitude length. Well, that's pretty cool. So that means it's going to equal H over whatever corresponds over here in this triangle, and that happens to be DB. Whoa, DB is that. Check that out. By the way, I hope that looks familiar. You better believe it does. It's exactly that right there. That is really cool. That is so awesome. Anyways, that is the theorem right there. It is going to be the altitude on hypotenuse theorem. And this is part B, where we just again are dealing with the altitude. The altitude length, whatever it is. That thing right there is the mean proportional. So they go in as the means, as you see right there, between the individual segments of the overall hypotenuse. Bam, there you go. This is a very powerful theorem. You wait till you get to part C, but we're going to rock and roll and do a bunch of examples with this. Go to the example video and you're going to see 4 examples that I did using exactly this theorem, and you will become amazing at doing these questions. We'll see you in class. Later.